Hello everyone, and welcome to the first session, just an introduction to our course entitled Air Navigation Systems of the Master in Aeronautical Engineering. I'm just recording this in case you cannot attend the lecture today. I'm going to try to touch base on the most important things you should know for the course, right, in terms of schedule, organization, and so on and so forth. So we'll basically talk about teachers. We will introduce, right, and define what air navigation is, and then go through the teaching guide, including competencies, syllabus, learning activities, the schedule, evaluation, and so on and so forth. These are the teachers. This is Manuel Solaris, myself. I have the office in 7.18 and H18, Juan Bennett. Office hours will be set from Tuesdays right before the class, from 1 to 3. Of course, they will be probably on a virtual basis. You have my email in the slide, and you can always reach me via email, and I try to answer always on a daily basis. Sometimes I'm very busy, so please wait for my answer. I am the coordinator of the course. I'm going to be teaching all the theoretical lectures and also attending to most of the labs together with other colleagues. Here you have two PhD students, Aniel Jardines and Rodrigo Castellanos. They are going to be teaching together with myself some of the labs. Aniel is he's aerospace engineer. He was trained in Georgia Tech, in the United States. He's also a private pilot, and he's a PhD student of myself, doing things related to artificial intelligence and data science applied to air traffic management. And then Rodrigo is a former student of this master, and he's doing a PhD on things that have, in principle, nothing to do with the topic. But he will just be teaching three labs, right? And then I annotate here also Javier Lloret and Javier García Eras. They are not going to be teaching any lecture this year, but they were somehow involved in the preparation of some of the labs. It took a lot of time, and you might be also hearing their voices because they recorded a couple of videos, and eventually they might assist us if needed eventually, right? Good. Now, as for introduction to the course, so the first thing, what is air navigation, right? Air navigation basically, I always try to bring here a dual definition, which has to do with a dual concept or a dual vision. On the one hand, you have the process of steering one single aircraft in flight from an initial position to a final position, right? Can be from an initial origin airport to destination airport, or initial fix to a final fix in a given route. Following a given route, right? That's important. We need to track a given path, including a given altitude, given speed, and eventually fulfilling requirements of safety and efficiency. And that's one definition, and this has to do with altimetry, anemometry. It has to do with the basics of air navigation, reading a VOR information, DME information, navigating towards a VOR, navigating towards a DME, landing using ILS and following a approach procedure, GNC concepts, right? Inertial navigation, estimation techniques, all the instrumentation you have on board, right? So it's more linked to the activity a pilot would conduct, right? And all those systems, instruments, engineers must design to be on board, right, in order the pilot to reach destination in a safe and efficient manner. But if you look at the right hand side, you will see that we are not alone in the sky, right? Every day in Europe, well, not these days as you might imagine, but back in 2019 we had around 30,000 flights per day crisscrossing the European skies, just the European skies. And as you might imagine, this is quite a complex system to be handled. So we need to put in place procedures, processes, rules in order to ensure that not only one flight can be steered towards destination in a safe and efficient manner, but all of them, right? As a complex system. And thus, air navigation is also has to do with all those processes that make possible air transportation day after day, right? And here we always talk about air traffic management, airspace management, so how the airspace is structured, air traffic flow management, how flows are organized to identify hotspots and eventually avoid them, avoid potential danger. Air traffic controllers, which they are monitoring the evolution of traffic and eventually instructing an advisory, right, to turn left, right, to climb up or descend to avoid a potential conflict. We also here we might be talking also about meteorological information that is relevant, aeronautical information such as charts, and so on and so forth. Right? You have also two videos to illustrate these two concepts that you can watch yourselves. Now, as for the teaching guide, this is some official document that well, I mean, these times is complicated because things are changing, and we in principle are starting in situ, but we might go remote. And well, I mean, in principle here you have kind of it's a learning agreement for those of you coming from outside Spain as exchange students. This is kind of the letter of agreement you have, certifying what you have studied, right? You have the contents and you have the methodology and so on and so forth, just for you to check. Then as for prior knowledge, well, we in UC3M we have a bachelor in aerospace engineering, and we have a lecture or a topic called or entitled Aerial Navigation, Air Transport and Airports. Aerial navigation gets typically half of this course, so 3 credits, in which we touch all these basics of air navigation, the ATM CNS concept, meteorology, altimetry, anemometry, airspace management, flow management, air traffic control, communication, navigation, surveillance. Well, on the left-hand side, you have a book by my colleague Javier Lloret. He was teaching this course. Has been teaching this course since 2014, and he just quit last year, and he published a book which is the one we follow. I think from chapters 1 to 11 or 12, right, depending on the edition. You have the link. I think it's 13 euros. Should you want to buy it, it is also available for you at the library. For those of you with no previous knowledge on the topic, I would strongly recommend you to buy it and take a look at it. Also, you can get a kind of overview reading chapters 10 and 11, which will be made available for you via Aula Global, of this other book, which is a book I published, is open source in a subject that I was teaching a while ago already, right? And this is probably more kind of synthetic information. In any case, we'll cover in as you're gonna see in 2 sessions, kind of the basics, right? So that you can catch up with the topic quick. As for the syllabus of the course, well, I have to say that the course is structured or pivots around a flight, right? What do we need, right? What type of services do we need? If we were intending to fly from one airport to another, right? Say in 6 or 8 months, we were planning as an airline. So we have kind of different temporal layers: tactical, pre-tactical, strategic. So strategic means months before the flight takes place, down to the operation, the tactical phase, the execution of the flight, right? And we have different agents involved: the airline on the left hand side, We have the network manager. In Europe is the Eurocontrol, right, which is somehow collecting information. We have their navigation service provider, ENAIRE in Spain, on the right hand side, and we have the airports, right, which are not relevant to us, but you are also seeing information, or you are studying airports in another lecture. Se me está raro. They were asking for a coffee, but what we're gonna see, this is divided in 6 blocks, and besides touching the different elements that we need for flight, including flight planning, flow management, air traffic control, we're gonna repeat topics or things that you have already studied, but we're gonna also incorporate optimization as a transversal discipline, such a way that we're gonna solve ATM or air navigation related problems using optimization techniques, right? So that's what we're gonna do. And if you see, we're gonna block 1 is on navigation fundamentals, which is basically a review of what you already know. Then operational procedures, going from instrumental flying rules, instrumental operations, conventional navigation, which is what we did in the bachelor, to RNAV navigation, performance-based navigation, right? Which is what we're gonna do in the master, including the simulation of a flight. We'll get into guidance, navigation, and control, Kalman filtering, inertial navigation, which has to do with the way an aircraft computes its state, position, velocity, using internal information, accelerometers, gyroscopes, and then by taking advantage of external measurements, navigation equipment on the ground or on the space, we can estimate the position, which is the position and the velocity, and in general the state of the aircraft, which is what we would present to the pilot in the cockpit, in the instruments on board the aircraft. Then, as I was mentioning, optimization. Most of the labs are going to be dealing with optimization. We're going to solve a flow management problem. We're going to solve a conflict detection resolution, an arrival manager, and then we'll finish with ATM performance, a way of measuring whether the system is working better or worse in terms of safety, in terms of efficiency, in terms of environment, in terms of capacity, right? Those are the things we need to measure, because in the end what we want to do is to understand how the system works today, what are the gaps from a technological point of view, from a mainly technological point of view, and how can we improve the system, right? So we're going to take a look at also the future system for navigation linked with a European program called CESAR. We'll have 2 sessions on that in order to kind of wrap up, right, the whole course. So the idea is that the first 4 blocks are linked to what we do today, to understand gaps in efficiency, to learn a bit about tools, techniques related to optimization in this case, that can be used to improve the way things are done today, and in the end being able to measure in case we implement a new technology, a new procedure, something in the system. We should measure whether this is improving or not, and in which areas, and then we will link this with the technologies that are being developed today in Europe. Okay, so that's kind of a syllabus of the course. Now, here the idea is that in the end we will be flying, and here you have pilot, FMS, right? And here you have a couple of videos on what CESAR is. A video you can watch also in the YouTube channel, because it's list. And here you have the CESAR website, right, for this last block of the syllabus. As for learning activities, well, the idea is that we're gonna go for a flip classroom concept, which might be new to maybe many of you, maybe not, I don't know. The idea is that given the situation, I do consider this type of teaching the best one, right? Because it's flexible enough to allow people which might be ill with the virus or just confined at home to follow the lectures in a good way. It might also allow myself in the same situation because I have kids at a school, and if there is one classmate of my kids with a positive with the virus, then we have to be, all of us, we have to be like 14 days at home, right? So it will also allow myself to keep teaching the class from remote on a similar way, right? So the idea is that we are not going to have theoretical lectures. These are substituted by videos, and for that we have the YouTube channel that you can click using the slides. You can see it, and classes will be devoted to use cases, accidents, and other things that might be relevant to the lecture, exercises, right, and evaluation tests. You're gonna have 20 minutes, half an hour, 40 minutes to complete a test on the theoretical elements you should have watched beforehand. We'll do laboratories in classrooms, right? So you must bring your own or borrow laptops always, every single day, right? So I hope you will have it. And still we'll do most of the work is going to be individual because we cannot, like discuss and gather together. But I understand that you're going to work as groups to fulfill the assignments on a virtual fashion as we are already used to do, right? In previous years, as you might imagine, well, we were going to Madrid Torrejón Control Center, to the simulators. This year, this is not going to be possible, so this has been cancelled. All right. Here you have Moodle, right, in which all these learning activities are going to be uploaded. Sorry. As for the teaching methodology, right, this flipped classroom, you can see it down here, right? You can see it down here. Before the class, say you'll have the information 2 days in advance, you'll have the theoretical content already in videos. How many videos and how long? That's the question. Well, my idea is, I am not a machine, so I don't know, but my idea is to try to stick to the 1 hour and 40 minutes we have to teach theoretical lectures. So you'll have maybe 1 hour 30, 1 hour 25, maybe one day is 145, 150 altogether, right? So that it is more or less same length as in a theoretical lecture. You should study, watch the videos as if you were attending to class right before the class, right? Imagine if it is a Tuesday, probably you'll have information on Sunday, you'll have Monday morning, Monday evening, Tuesday morning to watch the videos. How you should watch the videos? As if you were attending to class, right? You don't need to pause it, to reproduce it several times, because otherwise this is infinite amount of time. You should take your own notes, right? You'll have the slides, you can print out, or you can use a piece of paper and just write. You're watching the videos. In the videos, sometimes it's a presentation, sometimes it's myself on a board writing, sometimes it's a video that you watch together with myself. So I mean, the pace should be similar that the pace that you would be following in a class, right? So this is important that you also learn the best way for you to follow the classes. But you should more or less employ those 2 hours to study the material, not more, as if you were attending to class. That's the idea. You take your notes, you understand more or less the concepts, and then you come to class. In class, I will probably start with a summary, highlighting the most important concepts, and then we'll solve, or I will propose one exercise or one use case. Maybe you have to watch a video for the use case and discuss it yourselves. And then we discuss a bit on that. Some days we will be solving exercises, maybe you first of all, and then I complete the solution. We will see how this evolves, right? Some days, when it comes to some days, will be fully devoted to solving problems in class with the computer software, right? The labs, assignments. You will have time in class devoted to progress in those assignments, and the statement will be given and explained beforehand as well, so that you hit the ground running, as this expression in English, right? So you come to class already with an understanding of the statement for the assignment, and you can just come and work, and I'll be there, of course, to solve any issue, any problem. We will use Blackboard Collaborate, even in class, to share screens. We will see, right? And then the last thing, if you go to the figure again, after in the flip classroom after the class, we should check whether you have acquired an understanding of the topic, right? Instead of doing this after the class as an additional assignment, we will dedicate the last 20 minutes, half an hour, to complete a test via Aula Global. It will be, in principle, easy, right? Just double checking that you have actually watched the videos and more or less understood the topics. There may be 1-2 questions a bit more involved, but in principle, the idea is that they should be easy enough so that if you have employed those 2 hours, right, to revision the contents of the course, you should be able to complete the test. And of course, this test will be evaluated and will be part of the continuous evaluation, right? I think it's a good way to provide you with a routine, right? Because otherwise you might have the videos, you might start not watching the videos, so coming to class without the global understanding and the knowledge we need to actually have an interesting discussion, or actually solve problems, because otherwise it doesn't make sense, this type of content, right? So we need to have something forcing you or motivating you towards watching these videos and following the lectures. We keep going. This is the kind of schedule. We have 27 classes this year. Typically the 28th was devoted to Madrid Torrejón visit. We should have 28, but this year we cannot recover classes. So in the end, I ended up with this schedule, in which you have today introduction plus definition. Then we have 2 classes devoted to review. Review is a review of what some of you already know, but is part of the subject, right? We'll have quizzes associated to them, or tests associated to those 2 lectures on Thursday and next Tuesday, and you'll have some videos from the bachelor, together with some exercises or use cases, and it's part of the course for 2 reasons. Well, for one main reason, because this is established in the BOE, right? In order to become an aeronautical engineer, as in this master, you must have a series of courses with a series of contents, and they are forcing us to touch airspace management, air traffic flow management, communication, navigation, surveillance, altimetry, anemometry, all these things, and we need to check them, right? To say, yes, we are covering them, and they come and ask, and this happened last year, and they specifically ask where we were covering the communication and propagation of electromagnetic waves. And the answer is, we already covered in the bachelor. We don't want to recover it here, because otherwise it would probably make no sense. But we need at least to cover it to some extent. Right? So at least we have these 2 lectures that I understand that on the one hand might be a repetition for some of you, but it's just 2 lectures to warm up, to kind of remember a few things, to catch up with the topic. And for those of you that are new into the topic, it's good because you get to kind of the same level of knowledge. Of course, for those of you with no prior knowledge, it might be hard because it's kind of packed information, but you need to make that extra effort in this week, 2 weeks to get to the same level. Okay, then this has to do with procedures, performance-based navigation, including a flight plan assignment that goes a bit more, a bit beyond what we did in the bachelor. Then we start with optimization, right? With introduction to software we're going to be using, called Ample, linear integral optimization. This is a theoretical lecture on the main fundamentals of this. Kind of warming up laboratory on linear and integral optimization problems. Then the GNC block, and then we move into modeling the air traffic flow management problem as an optimization problem and solving it right here. Then the flight simulator lab, similar to the one we did in bachelor, but this time instead of conventional procedure is RNAV procedures, so it's quite different. We're going to use the flight computer on board, and it's a different thing. I think this is a nice practice, and we will get to learn all the things. Again, back to the optimization, now non-linear optimization. It's not anymore linear and integral, but non-linear, associated to conflict detection and solution algorithms, and a lab associated to detecting conflicts and resolving conflicts as if we were designing a human decision support tool for the controllers. Then ATM performance, right, measuring the system, and 3 labs simulating the ATM system, which are somehow linked to ATM performance, but also to flow management and conflict resolution. Is a way of simulating a solution that we want to test. Is what we do in air navigation typically. And then SSR 1 and 2, this is linked to the future system of air navigation, right? And finally, we'll do a laboratory exam in class, which will try to assess whether you have understood and whether you have acquired the competences that we are trying to teach you in the different labs. You see that we have 17 quizzes all through the course. When there is an assignment, typically you don't have quiz because the lecture is devoted to working the assignment, and then you have to hand in the assignment. But in all the rest, there are theoretical or half theoretical, half practical. You have some associated quizzes. In this one, in the simulator lab, you have also quizzes because there is no assignment associated to this one, right? So the idea is that you show your understanding via quizzes. As for the laboratory, we have 2 sessions devoted to the flight simulator, and here you have the video to the flight simulator lab. Optimization, again, 2 sessions. Flow management, collision avoidance or conflict detection resolution on the 2 sessions, and then the simulation lab with 3 sessions but no assignment, and then the flight plan exercise. So these are the assignments, labs, or homework that we will do together. Here is the calendar. Needless to say, you have the schedule, Tuesdays, Thursdays, how it goes, session 1, 2, 3, and so on and so forth. We have just one off day, which is here in December the 8th. We still don't know when the exam is going to be, but I understand that in January. And here's the grading, right? This is a course that is very oriented towards continuous evaluation, and thus we have this 75% continuous evaluation, including the flight plan exercise and flight simulator, 7.5% each, optimization lab 5%, these 2 flow management and conflict detection resolution lab 12.5% each, quizzes 15%, but I'm gonna just take the best 14 marks out of the 17. Sorry, here there is a mistake. Out of the 17 tests, right? So in this manner, there are 3 of them Imagine you cannot attend a lecture. I mean, quizzes, you could do quizzes from home, okay? This is not a problem because this is going to be done the aula global. But imagine you cannot study or you cannot follow the topics one day because you have another assignment, or you are ill, or we will see, right? At least you have three that okay, if you get a 0, it's not a problem. And then out of the best 14, then I'll take the average. That's the idea, okay? And then just for the laboratory, computer-based exercises, another 15%. This makes 75. And then the final exam 25. In the final exam, you need to get a 4 out of 10 in order to weight the continuous evaluation with the final exam mark. If in the final exam you get a 10, then typically we try to respect, right, that mark and make it the best among the final and the weight of the final and the continuous evaluation. But this is typically not the case. And in the final exam, we will have theory and exercises, but no computer-based exercises. Okay. This is the estimated effort, which is important, as I was saying. I mean, more or less, this is what we think you should employ to assess all the topics and the assignments. This is if you have properly assimilated the previous knowledge. If not, you should probably study a bit more. And this is for a 7, right? Which is not a very good mark. Of course, if you ambition to get a 10, probably you should increase the dedication a little bit, right? You should be attending to class, studying, which means now before class watching the videos, right? And you don't need to study the 29 or 27 lectures because some of them are laboratories, right? So you can dedicate the time of class to some of the laboratory, but not to further study because in principle this is associated to the assignments themselves, okay? In the simulation software, you're going to be doing everything in class, plus some study, so there is no associated hours. Then to study the exam, and the exam itself, all right? As for bibliography, there is nothing very suited to this master, I would say. So we have the books we have already presented, but nothing else. We can get, sometimes I will refer you to papers, sometimes I will be referring you to specific chapters. I was preparing some lecture notes, but provided the current situation, I'm going to focus more on the video, so it's going to be impossible, but I will give you eventually some notes. You have the slides, you have the videos, your own notes, plus some documentation I might handle over to you, and this should be enough. It should be enough for you to follow the course. Nothing else on my side. You have other books that you might want to check as additional information. If you're very interested in the topic, come to me and I can refer you to specific books on different topics, right? For instance, this is modeling optimization. This is for optimization purposes applied to air navigation. This is more mathematics of air navigation. This is El Sistema de Navegación Aérea in Spanish, more general books. This is inertial navigation, etc. So thanks very much for your time and welcome to the course. Bye bye.